going to try solving some linear systems type word problems. So what we're doing is we're looking in each case for two variables that are related to one another. In other words, when you change one variable, the other variable has to change as well. So to describe that, if you take a look at this situation here, I have the equation 2x minus y equals 4. If we set x equal to 5 in this equation, so if this becomes a 5, we have 10 minus something is 4. Well, that something must be 6, so y must be 6 in that situation. You can work it out, the algebra, on your own. If we happen to change the x from a 5 to a 6, that forces the y to change as well. For this equation to stay consistent and stay equal to 4, we'd have 12 minus something. In this case, 12 minus 8 is 4. So when we change the x, it also changes the y. Thus, x and y are dependent on each other. That's what we mean by finding two variables that are related. When one variable changes, the other variable has to change in any situation we're working with for these types of questions. So once we find our variables, we then need to create a relationship between them as a pair or system of equations. So for our first example, we're just going to use a question similar to what we've been working with already. In this case, Jeff is a cashier at a grocery store. He has a total of $580 in bills. He has 76 bills consisting of $5 bills and $10 bills. How many of each type does he have? So in this case here, how many of each type does he have? Well, what do we have that has different types? Well, we have these $5 bills and $10 bills. So those would be our two variables. So we have $5 bills, and we'll use the letter F to represent the number of $5 bills, and the letter T to represent the number of $10 bills. So we have our two variables. Now we have to relate them. Well, our first sentence doesn't give us much information for solving the question, but he has a total of $580 in bills, and he has 76 bills made up of the $5 and $10 bills. Those two pieces of information there are separate from each other, but give us two distinct equations we can create. The easy one is that he has 76 bills. So the number of $5 bills plus the number of $10 bills is equal to 76. Sorry, ahead of myself. 76. And now he has a total of $580 in bills. So each $5 bill is worth $5. Each $10 bill is worth $10. So the value of the $5 bills is 5 times F, $5 times the number of bills we have, plus 10T, $10 times the number of bills that we have. And that equals our total of $580. Now we have a system of two equations that we can go about solving. We can use graphing in this one if we wanted to, and we can use graphing because if we look at the items, $10 bills and $5 bills, he's not going to have half a $10 bill or a quarter of a $5 bill. He's going to have a whole number, so that makes it easy to graph. However, we're working with fairly big numbers, and so we're going to avoid graphing because 580, that can get be a pretty big graph. So we can use substitution or elimination. I'm going to use elimination here. And to do that, I am going to get rid of the t's. I'm going to multiply everything in the first equation by 10. You could also multiply everything in the first equation by 5. It doesn't matter. I think 10 is just an easier number to work with. So if I multiply everything by 10, I'm going to have 10f plus 10t equals 760. And in the bottom equation, 5f plus 10t equals 580. We're not changing that one. Now, I can go about subtracting these two, if I subtract these, it'll get rid of the t's. So 10 minus 5 is 5f. There's no more t's left. 760 minus 580. Borrow from the 7 here. I got 16 minus 8, and I'm going to get 8, and 6 minus 5 is 1. So 5f equals 180. And now if I go about solving this for f, I just move that 5 over to the other side. It's multiplication here, so the opposite operation is division. 180 divided by 5, f equals 36. So we have 36 $5 bills, and then our $10 bills, we substitute that into this first equation. So 36 plus t equals 76. T equals 76 minus 36. T equals 40. So I have 36 $5 bills and 40 $10 bills. And we can write a little statement. Therefore, Jeff has 36 $5 bills and 40 $10 bills. Now, another type of question that we often work with is speed questions in linear systems. We have something happening in two directions, and in this case here we have a helicopter pilot that's traveling with a tailwind and then a headwind. So as you're traveling, the helicopter's here, and here's my little helicopter. As it's traveling one way, the wind is going to be pushing on it, and that's going to make it travel faster. But when the helicopter turns around, the wind is going to be pushing into it, and it's going to slow it down. So this here is a tailwind because it's coming on the pushing towards the tail, and then this one is heading into the wind, so it's called a headwind. And this is the same for airplanes. You may also encounter the situation where someone is going upstream and downstream, so against the current and with the current. Same kind of setup for questions like that. So when we have a situation where someone's being affected by either wind or current of water affecting their speed as they're moving, then you're going to have a setup similar to what we have here. So in our specific case, a traffic helicopter pilot finds that with a tailwind, her 120 kilometer trip away from the airport takes 30 minutes. So that means the wind's pushing her to go faster. And then on her return trip into the wind, it takes her 10 minutes longer because the wind is pushing against the helicopter, making it slow down. What is the speed of the helicopter? What is the speed of the wind? So in this case here, you're given the two variables that you're looking for because you directly asked for them. The speed of the helicopter, speed of the wind. So we use h for the speed of the helicopter. I misspelled that. Helicopter. And we'll use w for the speed of the wind. Now, something that's useful in these types of questions is making a little table that will help us out. So it's important to note too when we're working with speed, and this is a formula that you'll use in physics as well. Speed is equal to distance divided by time. Or if we rearrange this, distance equals speed times time. And we're going to use this fact here to help us out in solving this question. So we'll make our table here. We need the trip away, and then the trip towards the airport. we have a distance that we're given here. We're given a distance. We're gonna have to figure out a speed, and we know the times. So there's our three parts that we need, and so if we fill this in, we have the distance in both cases, away and towards, is 120. The time, well, the time away is 30 minutes, and then it's 10 minutes longer, so that would be 40 minutes when it goes back towards the airport. Now the speed of the helicopter away from the airport is the speed it's going, plus it's also getting pushed by the wind to go faster with that tailwind, so speed is the speed of the helicopter plus the speed of the wind. The total speed going back is the speed of the helicopter minus the speed of the wind, and that there gives us all the information we need to create our equations. So knowing that distance is equal to speed times time, we can translate that into an equation like that. So away from the helicopter, the distance equals the speed times the time. Going towards the helicopter, the distance equals the speed times the time. Now, important to note, we're given time in minutes. When we calculate speed, we tend to use kilometers per hour. So we're actually going to tweak our times here and make them into portions of an hour. So 30, I'm actually going to change to half an hour, and 40, I'm going to change into 2/3 of an hour. And I should just redo this in that point. All right. What do we got here? So now to fill in our table, we have the distance is consistent in both cases as she travels away and towards the airport. She's traveling 120 kilometers. The speed in both cases is going to, or in each case, is going to be slightly different. As she's traveling away from the airport, it's the speed of the helicopter plus the wind that's helping her out, that tailwind. And then as she's traveling back towards the airport, it's the speed of the helicopter minus the wind that is slowing her down. Now the times, because we want a speed, generally we do not use kilometers per minute, we use kilometers per hour. So we're actually going to change our times here. Our 30 minutes here, that's half an hour or 1/2. And the 10 minutes longer, that's 40 minutes, that is 2/3 of an hour. And I'm leaving fractions because you will get a slightly different answer than me if you change these into decimals. The 0.5 is nice, but this is 0.66666 repeating forever. You'd round that to 0.67 and that would slightly tweak your answers. So I'm going to use the fractions and keep the accurate answers. So here we have our table filled in, half an hour, 2/3 of an hour, our two speeds, and our distances. We can now use this formula, distance equals speed times time. So distance equals speed times time to create two equations. We now have our two equations, and with a little bit of rearranging, we can easily solve these. So I'm going to rearrange these a little bit, and in the case of equation 1, or the away formula, it's going to rearrange to 120 equals h plus w times a half, and I'm going to take that half and divide the other side by 1/2. If I divide 120 by 1/2, I have 120 divided by 1/2. I guess I don't need the brackets anymore. 120 divided by 1/2 is going to be 240 h plus w. And if I rearrange the second equation there, I have 120 equals h minus w and 2/3. So 120 divided by 2/3 is equal to h minus w. And so 120 divided by 2/3 is going to give me 180 equals H minus W. So now I have two nice, easy equations to work with, and I'm just going to flip the clear the screen here, and then we'll start off with these two equations. So let's just finish off this question here now. I got 240 equals H plus W and 180 equals H minus W. So those are the two equations. I'm going to use elimination because that looks like it'll be nice and easy. If I subtract these, I will get 60 equals H minus H, it disappears, and W minus negative W is going to give me 2W. And so 60 divided by 2 equals W, or 30 equals W. So there's my wind speed, 30 kilometers an hour. And now I can just substitute that into one of the equations here. 180 equals H minus W, so 180 equals H minus 30, or 180 plus 30 equals H, which then gives me 210 for my H. So there's my speed of the helicopter in kilometers, 210 kilometers an hour. So the wind is 30 kilometers an hour and the helicopter traveled at 210 kilometers an hour. Now anytime you're working with speed questions, again, this is the same kind of setup. This last portion here, this is just substitution or elimination. Substitution works here as well. If you want to rearrange one of these for H or W and solve it, that's perfectly fine. Whichever method you wish. I found elimination was a little quicker for me. Either method works. You could even graph this one in this case because they do end up being even numbers, but ideally with the big numbers like that you'd want to use substitution or elimination. Any question you have that has a speed type question, this is the first type of thought you should have. Any questions that we are going to be taking up on the tests or on assignments with speed, this is the situation that you'll have. So this second portion here again is just substitution elimination. It was the earlier portion before we cleared the board that was actually setting up the equations. So again, make that table and use that idea of that table with your variables, with your different pieces of information to create an equation. Now for our last type of problem that we'll be working with, it's percent mixture problems. So we're mixing different chemicals or maybe ingredients at different proportions, and so we want to balance them out. In this case here, what we're looking at, and this is often used in chemistry ideas, a lab tech needs 3 liters of an 8% saline solution. Saline solution means 8% salt, that's the saline, in water. So a saline solution is salt in water. So we need 3 liters of solution where 8% of that 3 liters is made up of salt. On hand, she has a 5% saline solution and a 9% saline solution. So we need to figure out how to mix those two together in what ratio to get the required 8% solution and 3 liters of it. So similar to our speed problems, we can set up a little table to figure out what we need here. So if we let F be the amount of 5% solution, and N be the volume of the 9% solution, we can now make a table that will relate these variables to the amounts of material. So we have volumes of solution in total. So this is we're going to look at the volume of solution, and then we're just going to look at the volume of salt in the solution, that 5 and 9%. So the volume of salt. So in the 5% solution, the amount of solution, there is F. We need F amount. So whatever volume that's what we're trying to find. We're trying to find out how much of that we need. How much salt is in there? Well, 5% of this total volume is salt. So 5% or 0.05 times F. This is the amount of solution. This is the amount of salt that would be in that solution. In the case of the 9% solution, it's very similar. We have N liters of it that we need, and there is 0.09% of that being salt. So 5% of the total volume, 9% of the total volume, and so we finally need our 8% solution. And we need 3 liters of that in total. And of that, how much is salt? Well, it's an 8% solution, so 3 times 0.08, and that will give us our percent of salt in that solution. So we'll have that much salt, and that much is the total volume of the water and salt mixed together. So if we look at this, again, our total volume we're looking for is 3. So if we add the amount of 5% solution to the amount of 9% solution, that will give us our total volume there. And this is the total volume of salt. And if we add how much of the 5% salt and the 9% salt solutions we have, that will tell us the total amount of salt. So that there gives us our 2 equations, which we can now go about solving using substitution elimination. Here I wouldn't recommend using a graphing method because 5 and 9%, these are small decimal numbers, are going to be hard to put onto your grid. So if we go about solving this now, we'll just set these equations together, and I'm going to use the method of elimination again. So we initially had 5 plus n equals 3, 0.05f plus 0.09n equals, and if we actually multiply that out, 3 times 0.08 is 0.24. So I'm going to get rid of the n's, and so I'm going to multiply this top equation times 0.09. Again, substitution would work here as well. You'll get the same result. 0.09f plus 0.09n equals, and 3 times 0.09 is going to be 0.27. And then the next equation just writes out the same. So now, if I subtract these two, I'll be able to find f. So I subtract these, 0.04 f, and then here we have no n's left over, and then we subtract those, 0.03. And then to solve for f equals 0.03 over 0.04. This ends up being 3/4 or 0.75 liters. So we have 3/4 of a liter here of the 5% solution, and then we just sub this into the original equation to solve for the amount of 9% solution. So using that up here, we have 0.75 plus n equals 3, using this initial solution here. And then if we solve that, n equals 3 minus 0.75, or n equals 2.25. So we have 2.25 liters of the 9% solution. And so a little therefore statement somewhere at the bottom here. Therefore, she needs 0.75 liters of the 5% solution and 2.25 liters of the 9% solution. So again, like the speed questions, if we set up a table looking at the total amount of material we need. In this case, it was a volume of liquid. We needed 3 liters, which is the 5% solution liters plus the 9% solution liters. So we add up our total volume here, and then this is the proportion of whatever mixture we're looking at. So the percentages add up here, the percentage of salt, and the percentage of salt. So we added up all our salt percentages together. So you use that table, and then you should have a setup very similar to this, both in speed and in the solution questions. You can set up quick and easy formulas that way.